we'll discuss some question. So that question is basically related to limits for function of one variable. And
So
after
your voice
that,
is very low, sir.
okay, my voice is low.
Yeah.
No, sir. Okay.
So now is it clear?
Yes, sir.
Okay.
Yes, sir. Now it is clear.
So yeah, so the fast 1.5 hour, mostly we'll discuss some activity questions. So all these questions, they are basically related to limits for functions of one variable. So after that, you can ask your doubt, like if you have something which which yeah, which is outside the things that I'm going to discuss, you can ask after that. So okay, so let me share my screen. So yeah, so can you see my screen?
Yes, sir.
Okay, thanks. So yeah, so the thing is, yeah, so we are going to discuss limit for functions of one variable. So first, I will try to recall what do we mean by limits, and how, like, yeah. So yeah, so let's start with the definition of limit. So this is basically, so suppose you have a number. Suppose, okay, so obviously we are calculating limits for function. So the first thing is, you must have a function, right? You must have a function. Okay, so the domain of the function can be like can be a subset of R. So for our convenience, let's take the domain of the function is R. So suppose I have a function from set of real numbers to set of real numbers, and I want to calculate the limit of this function at a point A. So that is, X is basically belongs to domain of the function. So what we basically, what we want to calculate, the limit x tends to A. This is basically the notation for limit. So what actually, it's basically, what do we mean by this thing? So what basically we are trying to do, we are trying to find, so what actually we are trying to find actually, what basically, what f of x is trying to achieve. So as x approaches to A, right? This part is really important. So as approaches to A, what actually f of x is trying to achieve, like where f of x is basically moving as you move towards A. So as I told, domain of the function is basically R. So this is my domain, right? This is my real line. This is domain. So we want to calculate limit at a point A. So A should be somewhere on the real line. this is a. So we want to calculate the limit of the function f of x at this point, right? So the question is this particular statement as x approaches to a. So as you can see in real line, you have only two directions. So there are only two ways where you can come to a. So one way is basically you can come in this way.
Sir,
Yeah. Yeah, please.
sir, sir, don't we have a solve with instructor in maths too?
Yeah, this is the solve with instructor. So uh,
Okay, sir.
so like, yeah, so do you want me to skip the definition? Like I can directly move to.
No, it's okay, sir.
Okay, so the thing is, so yeah, so this is my point A. So what I want to do, so I can reach to this point A from this direction. That is, I can come to A from right hand side of A, and also I can come to A from the left hand side of A. So when actually I'm coming to right hand side, so basically what I'm so what I'm so I'm coming through through numbers which are basically larger than A. So this side, so all the numbers which are in the right hand side of A are larger than A. And whenever I'm coming from the left hand side, I'm coming through numbers which are smaller than A. So so suppose you have a function like this. So this is suppose A, this is maybe some f of A. So when you are coming from the right hand side, then you can see where f of x is approaching. So when you are coming from the right hand side, okay, so right hand side, so when we are coming through right hand side, that is x a positive, so you are coming to a from the right hand side. So you are using some numbers which are basically bigger than. So this notation basically denotes the right hand side, how the function approaches when you are coming to a through the right hand side of A. So we want to know how the function approaches when you are coming to the point A through the right hand side of A, and how the function approaches when coming you are coming to the point A from the left hand side of A. So for the left hand side, we'll use this notation. So how the function behaves when you are coming from the left hand side of A. This is called left hand limit of f at x is equal to A, and this is called right hand limit of f at x is equal to A. So these two things, they may or may not exist. Both the things, both left hand limit or and right hand limit, they may or may not exist. Suppose they exist. Suppose it gives you some value, that is maybe This is A. This is B. Okay, I made notice. Suppose this is A, this is B. So if A and B are equal, then we say limit of f of x, limit of f of x at A exists, and we will denote it using this symbol, that is A, which is same as B. So the definition of limit of a function is clear, right? Is there any doubt regarding the definition?
No, sir.
Okay, fine.
No,
Okay.
sir.
Okay, so let's do some problems related to the limit of a function. So yeah, so the thing is, this is what I have written. So this is x approaches to A from the right hand side. So as I said, when you are coming to the right hand, coming to A through the right hand side of A, you are actually coming through numbers which are bigger than A. And this will denote, this is basically, this symbol denotes the right hand limit, and this symbol denotes the left hand limit. If they are equal, then we say the limit of the function at A exists. Okay. Okay, so this is our first question. So the function, so we defined a function. So that this function is basically what? This function is 1 if x is greater than 0, and the value of the function is -1 if x is less than 0. So can you can some of you tell which of the following options are correct?
Of course. Sir, limit at x will not exist.
Limit at
X equal to 0
why?
will doesn't exist.
Why?
So since left hand or right hand limits are not equal.
Okay, so okay, so okay, so you should help me to draw the graph of this function. So this is the real line, and so according to the definition of function, the function value at x is 1 if x is greater than 0. So if x is greater than 0, so this is basically the positive real axis. So in this axis, the value of the function is 1. So this is, so this point is this x is equal to 0 is included here. So this is y is equal to 1. So if x is less than 0, then the value of the function is -1, less than 0. So this is this is the negative y axis. This is y is equal to -1. So so if x is less than 0, then the value of the function is basically -1. So this point is not included. This point is not included because, as you know, the value of a function at a particular point cannot give you two different things. Okay. So since we have already defined the value of the function at 0 is equal to 1, so we cannot define f of 0 to be -1. So this point is not included. So So this is the graph of f of x. This is basically graph of this particular function. Okay, so now we want to know which of the following options they are correct. So the first thing is it's saying that the first option is what? The limit of f of x at x is equal to 2 is -1. So x is 2. So this is x is equal to 2. So we want to compute the limit of the function at x is equal to 2. So as I said, first what we need to check, we need to compute the left hand limit, the right hand limit. If both left hand limit and right hand limit they are equal, then you can say that the limit at that particular point exists. Okay, so then this particular expression has some meaning. If the left hand limit and right hand limit they are different, then this particular expression don't have any meaning, because yeah, they are equal, so the limit basically doesn't exist. So okay, so so as you can see, so the left hand limit, sorry, so first we'll calculate the right hand limit of the function at 2. So as you can see, if you come sorry, if you come to this point, that is 2, from the from the right hand side, as you can see, the function basically approaches to 1, right? So that's why the right hand limit is 1. Similarly, if you come to this point through the left hand side, then similarly you can see that if you are coming to this, if yeah, so the thing is, as you can see, the function approaches to 1. So both left hand limit and right hand limit, they are basically 1. So they are same. So then I can say that the limit of the function at x is equal to 2 exists. Then I can write 2 is 1. So that implies my first option, this is, so the first option, it says the limit of the function at 2 is -1. So this cannot be true, because as you saw, the limit of the function at x is equal to 2 is 1. So the next thing is we want to compute limit of the function at x is equal to 0. So this is 0. This is origin, yeah. So as you can see, so yeah, so in the same fashion, like we need to first compute the left hand limit and then right hand limit. If they are equal, then we can say that the limit at of the function at that point exists. So yeah, so if you are coming to 0 from the right hand side, so in this direction, you can see the value of the function basically approaches to 1. This, because this is your y is equal to 1. Okay, so limit extends to 0 plus is 1. But when you are coming to 0 from the right hand left hand side of 0, from the left hand side of 0, as you can see, the value of the function approaches to -1. So what we are getting? So what we are getting, limit. So if you have some doubt, like you can stop me and ask your doubt, right? Like, so this is -1. As you can see, this left hand limit and right hand limit, they are not equal. So in this case, and right hand limit, they are not equal. That's why we can limit to 0 f of x does not exist. So second option is also wrong. First option is wrong. Second option is also wrong. So the next option is option 3.
Excuse me, sir.
Yeah.
So I think this is a kind of a very simple question. It will be better to move to the next one. Means already you all very much clear about the left hand or right hand limit. So should we go for the next questions, which are
Like,
somewhat complicated question? This is a kind of a very simple question.
yeah, what about others? Like, if all of you are fine with this, then I can move to the next question.
No, no,
Yes,
sir.
sir.
Please explain,
Yes,
sir.
sir.
Yeah, so
Please
then,
explain it.
yeah, then
So please continue, sir.
okay.
Yes, yes, sir. Please
Okay.
continue.
Okay, fine, thanks. So so yeah, so okay, so the first option is wrong, second option is also wrong. So the next thing is we want to compute so we want to compute the limit of the function at x is equal to minus 0.5. So this is my graph. So minus 0.5 should be somewhere here. So as you can see, when x approaches to minus 0.5 from the right hand side, you can see the function value basically approaches to this is -1, right? So when you are coming to 0.5 from the right hand side, then basically the function value approaches to -1. So that's why limit minus 0.5 plus is basically -1. And also you can see if you are coming to minus 0.5 from the left hand side, same, you can see that the value of the function approaches to -1. So both left hand limit and right hand limit at 0.5 is -1. So they are equal. So that's why we can say that limit of f of x at minus 0.5 exists, and that is equal to -1. So option 3 is correct. Option 4 says the left hand limit at 0 is basically -1. So we already calculated the left hand limit and right hand limit at x is equal to 0, and you can see at x is equal to 0, the left hand limit basically you want to check how the function behaves when you are coming to 0 from the left hand side of 0. So this is basically -1. This function value approaches to -1, and when you are coming to 0 from the right hand side, the function value approaches to +1. So the left hand limit at 0 is -1. So option 4 is correct. And the right hand limit at 0 is -1, which is not correct, because as you can see, this basically this is +1. So option 5 is wrong. So right hand limit at 0 doesn't exist, which is also not correct, because the right hand limit at 0 is +1. The limit of the function at 0 doesn't exist, which is true, because left hand limit is -1 and right hand limit is +1. So they're different. So that implies the limit of the function at 0 doesn't exist. So option 7 is also correct.
So can I ask?
Yeah,
one
please.
thing? Can you explain that option for that left limited extends to 0 minus once more?
Yeah. So the option 4, right?
Yes, sir.
So basically what you want to compute? You want to compute how the function behaves when you are coming to 0 from the left hand side of 0. So as you can see,
Okay.
if you are coming to 0 from this side, this particular value of the function is basically -1.
Okay. So you had to come from the left hand side. I thought it was to go to the left hand side.
No. You have to come to 0 from the left hand side of 0.
Okay, sir.
So that's why this is -1.
Okay.
Anyway, option limit of the function doesn't exist at any real number, which is certainly wrong, because as you can see, limit of the function exists at -0.5. And also you can check, actually limit of the function exists at all points except this 0, because as you can see, 0 is basically it actually creates the main problem, because here actually you have a jump, like, so if you are coming from here and suddenly at 0 you have a jump, so that is basically the only point where the limit of the function doesn't exist. Okay, so I think so this is clear, right?
Yes, sir.
Okay, so let's move to the next question. So yeah, so okay, so the thing is, when you want to compute the limit of a function, it's always better try to draw the graph of the function. Like, obviously sometimes it's really difficult to draw the graph of a function, but yeah, if it is easy, then you should try to draw the graph of that particular function. So yeah, so here the value of the function, so here the function is f of x is x if x is less than 2, and it's constant if basically it's the value is 5 if x is greater than 2. Okay, so let's so try to draw this function. So f of x is equal to x. So this is x is equal to 2. So f of x is equal to x if x is less than 2. So that implies this has to be the straight line, y is equal to x. So at point 2, the value is basically, so f of 2 is 2, right? Because x, for x less than equal to 2, the value of the function is x. So this point is included. If x is greater than 2, then the value of the function is 5. So this is 5. So for x greater than equal to 2, the value of the function is 5. So this point is excluded. Because because at x is equal to 2, the value of the function is 2. It cannot be 5. So that this particular point is excluded, and afterwards the value of the function is 5. So the first question, so it's basically asking the limit of the function at x is equal to 2. So so the same procedure. What we have to calculate the left hand limit, then we have to calculate the right hand limit. If both left hand limit and right hand limit they are equal, then we can say that limit of the function exists at that point. Otherwise, certainly the limit doesn't exist. So first we'll calculate the right hand limit. So as you can see, so this is 2. So if you are coming to this point from the right hand side of that point, so you want to know how the function behaves. So if you are coming from this side to 2, as you can see, the value of the function approaches to 5, because it's 5. If x is greater than 2, then basically it's 5. So if you are coming from the right hand side, so in all these points the value of the function is 5. So then the value of the function approaches to 5 if you are coming to this point from the right hand side of this particular point, that is x is equal to 2. So the right hand limit is then 5. Now we need to compute the left hand limit of the function.
Sir, but
Yeah. Yes, please.
fx equal to x, no?
No, f of x is equal to x if x is less than 2. Okay, so when you are coming from the right hand side, then x is greater than 2, right?
But at x,
Sorry. Yeah, please.
at x equal to 2.
No, the value. See, the thing is, you have to understand that the actual value of that function is basically irrelevant when you are talking about the limit of the function. Okay. So the thing is, you have to check how the function behaves when you are coming to this point from this direction. See, like suppose you take okay, so suppose you take this sequence, right? Is it a yeah, so suppose you take this sequence. I will take down, but in the end, so suppose you take this sequence. Okay, 2 plus 1 by n. It's basically converges to 2. So what actually you are doing, you are coming to 2 using this sequence.
Okay, fine.
Sorry?
Fine. Yeah, okay.
So when you will check, like if you check f of n, it's always 5, right? So for example, when n, so this particular sequence approaches to 2 from the right hand side of 2. So but if you check its functional value, it's basically approaches to 5. Right?
Yeah, right.
Yeah.
Yeah, right.
So that's why the right hand limit is 5. So now let's compute the left hand limit. So yes, in the same way, like if you are coming to this point from the left hand side of that point, then basically how this function is basically the value of the function is
2.
behaving. So as you can see, the value of the function approaches to 2.
2, yeah.
Yeah. So basically what we are getting, the left hand limit is 2, the right hand limit is 5, and certainly they are not equal. So
Yeah.
limit
Does not exist.
yes, true. Yeah. Not exist. So is it clear like how actually, so this is basically, see, the thing is, okay, so why I'm actually doing this basic thing, because yeah, maybe some for many of you these things are new. So yeah.
So thank you for that.
Yeah. Yes, because yeah, if you are checking the limit at x is equal to 4, so this is 2, this is 4, right? Then yeah, the limit exists, because when you are coming to 4 from the right hand side, then what the f of x basically approaches to 5. And similarly, when coming so the thing is, it doesn't matter how the function behaves here. The only thing it matters is how the function behaves the points which are very near to 4. Okay, it doesn't matter how this function behaves here or maybe behaves here. It doesn't matter, because it basically it matters how this function behaves at the points which are very much nearer to this x is equal to 4. So
And if we check for left hand limit at x equal to 4, it doesn't exist, right?
why when you
For
are
left hand limit.
at x is equal to 4,
Yeah.
why?
Just asking if it
No.
exists or not.
Obviously it's exist. See, you see, right? Like if you are coming to 4 from the left hand side of 4, right? Then you can see the value of the function is basically constant. It's 5, right? So the value of the function approaches to 5, right? So then both left hand limit and right hand limit, they are basically 5.
So basically limit does not exist at 2.
Yeah.
Rest at every point it exists.
Yes, true. Yeah. As you can see, like there is a jump here. Yeah. The problem is, see, as I said, so when you are calculating limit at this point, it doesn't matter how the function behaves here at x is equal to maybe 6. The only thing it matters how the function behaves in some so yeah, so it matters how the function behaves on the points which are very much near to that particular point. Okay, so yeah, so the thing is, you need to check how the function behaves on the points which are very much near to 4. Yeah. So as you can see, this, if you are coming to 4 from the left hand side of 4, then it's basically the value of the function approaches to f of 5. f of 4, which is basically 5.
So can we know what all will you cover in this session?
No, basically I'll cover limits of a function. Yeah.
Limits of a function.
So
Fine,
yeah,
sir.
so
Yeah.
so I plan to discuss some 5-6 questions. So
Okay.
so after that you can ask your doubt. Like, yeah, most likely, see, the thing is why I'm saying all these things maybe 2 times, because yeah, so these are the basic things. So
Yeah, no,
once,
that's fine, sir. That is
yeah,
what I wanted to understand. I have a particular question in reference to limits, which I wanted to ask in the last session also.
yeah.
The idea of
No,
joining in this session is so that my doubt can get clarified.
yeah,
That's
yeah,
what I
yeah.
was asking.
I'll discuss that.
Fine, sure.
Yeah,
Okay,
yeah,
sir. Thank you.
yeah. So yeah, so again, similar kind of function. So again, I guess now you can solve this thing, this question easily. So this is the function. This is the graph of the function. So it's the graph is given. So it's basically you have 5 options. So it's asking which of the following options are correct. So the first is limit at x is equal, left limit exists at x is equal to 1. So this is 1. And as you can see, the value of the function is 0, right? Value of this function is basically 0 here. So we want to know whether the left limit of the function at x is equal to 1, whether it exists or not. So
Yeah, it exists.
yeah, so if, as you can see, if you're coming to this point 1 from the left hand side, then basically the value of the function is 0. So the left hand limit is basically 0. So option 1 is correct. Left hand limit at x is equal to 3 is 2. This is 3. Hello. Okay, so I'm getting some noise. Like, can you unmute? Sorry, mute yourself. Yeah. So this is 3, and so we want to compute. We want to know whether left hand limit. Okay, so the left is basically asking what is the left hand limit at x is equal to 3. So this is 3. So as you can see, if we are coming to 3 from the left hand side of 3, this is 3, then the value of the function is basically, this is 2. This line is 2, right? So when you are coming to 3 from the left hand side of 3, then the value of the function approaches to 2. Right hand limit at x is equal to 2 is 2. I guess this is also correct. This is 2, and we want to compute the right hand limit. So if you are coming to 2 from the right hand side of 2, you can see the value of basically is 2. This is basically 2, that line y is equal to 2. So right hand limit at x is equal to 2 is 2, which is also correct. Limit exists at x is equal to 3. So we have already computed the left hand limit, which is 2. So to know whether the limit of the function at 3 exists or not, so we have to compute the right hand limit. Okay, if they are equal, then we will say that limit exists, otherwise the limit doesn't exist. So the next thing is we want to compute the right hand limit. So if we are coming to 3 from the right hand side of 3, as you can see, f of x approaches to 3. So right hand limit is 3. They are not equal. So limit at x is equal to 3 doesn't exist. So this option is wrong. Then next question is limit exists at every point in the interval x is equal to every point in the interval 2, 3. So this is open interval, both 2 and 3 excluded. So as you can see, so yeah, so the thing is, I already said it. So the thing is, it doesn't matter when you are computing the limit of a function. It doesn't matter how the function behaves here or maybe here. It's the only thing it matters how the function behaves on the points which are very much near to that particular point. So suppose you want to compute, you take a point in the interval 2, 3. Suppose I am taking this point. So I want to know whether at that point limit exists or not. So for that, I have to compute the left hand limit and the right hand limit. So what I am trying to, so as you can see, x approaches to this point. Suppose this point is C, from the right hand side of C. Then you can see that f of x approaches to 2. So that implies is 2 if C is in the interval 2, 3. Next thing is we want to compute the right hand limit. So similarly, you can see when x approaches to C, then the value of the function basically approaches to 2. So for all points in the interval 2, 3, the left hand limit and right hand limit exist and both are equal. So this option is correct. Limit exists at every point in this interval 2, 3. So is it clear? Hello?
Yes, sir.
Okay, thanks. So okay, so the next question is, so this is so you have this function and we want to know so we want to know what is the limit of this function at x is equal to 1. So before that, I want to write some of the properties of limit. So the thing is, limit behaves nicely with addition, multiplication, subtraction, or in some sense also with the division of function. So basically what I want to say, if limit is equal to a, so I have two functions f and g. So limit at a and b both exist. Sorry, limit at a for both the function exist. Then limit of f plus g at a is basically limit of f at a plus limit of g at a. And similarly for subtraction also, like this is basically you have only minus sign. And similarly in case of multiplication, f into gx, so these properties, they are really useful. Like the next thing is the division. So if b is non-zero, if b is non-zero, then only you can apply. Otherwise you cannot apply this this particular result. So these are 4 properties of limit. So okay, so let's go to the next question. So I want to compute the limit of this function at x is equal to 1. So what is can I factorize this polynomial?
Sir, half.
Sorry, yeah, the answer is half, but that is not my question. Like, can I factorize this polynomial?
Yes,
sir,
yes. X minus 3 into x minus 2.
X minus 3 into x minus 2. So as you can see, as x tends to 1, f of x so tends to 1 minus 3 into 1 minus 2, which is 2, right? So that implies you can do it like so I have actually omitted 2 steps, that you need to compute the left hand limit, the right hand limit. You can check like the both left hand limit and right hand limit, they are actually equal and both are so that value is basically 2. This is 2. So this is f of x. Okay, sorry, some notation problem. So this is g of x. This is g of x. This is g of x. And similarly, you can see as x tends to 1, h of x tends to 1. So here you can see that f of x is basically what? H of x by g of x. No, like here actually you can put x is equal to 1 directly, but sometimes it's not a good idea to put because as I said basically the actual value of f of a is basically irrelevant when you are computing the limit of that function. So sometimes the function even even doesn't exist, but still you will get a limit. Okay, so it's the so that is the thing, like you have to check whether you can you can directly substitute f of 1 or not. Okay, so that vary from function to function. So in this case you can do it. Yeah.
Sir, hello.
Yes.
Yes, sir. So we can do one thing. We can actually substitute the value of 1 and see if the function becomes invalid or not. Only in that case we can like solve it in this way. Otherwise, we can substitute the value.
Yeah, but the thing is, okay, but before that, you have to make sure that the limit exists, right?
Okay, sir. Sir, anyway, if it is if we substitute the value and we don't get the function as invalid, then we don't have to do all these.
Sorry, can you repeat?
Sir, suppose we substitute the value of over here x tends to 1
Uh,
and we are getting a proper value, then we don't have to rationalize or factorize or anything. We can just substitute and get the value.
no, like for this particular function, you can substitute the value, but you may not get the limit, right?
Okay.
So that is what I'm trying to say. Like it's completely depend on the given function. So as I said, for this particular function, you can do it. Okay. So yeah, because it's a nice function. Okay. So yeah. So we'll read in week 2. What do you mean by nice? Okay. So
are you suggesting that we apply the left limit and right limit and check? I'm sorry, I missed. I think the point here.
no, the thing is, so one actually some Tushar maybe, or yes, he actually he asked whether we can directly substitute the value to get the limit. So I was trying to so yeah, basically what I was trying to say, that you cannot do it for all the function. Okay.
Yes, sir. I was not saying for all the functions. I was only talking about some function where the function is not becoming like 0 by 0 or infinity by infinity.
Yeah,
if
yeah.
you are
So
not
yeah, so because see here actually the function is basically it's a quotient. Yeah, so it's a fraction, and both denominator and numerator, they are polynomial, right? So that's why you can do it. Yeah, true.
So how we will get the left limit and right limit?
Sorry.
Sir, if we want to check the left limit, how we should proceed, sir?
Okay, so yeah. Okay, so let me explain this. Then I'll go back to your question. So
okay, sir.
So yeah, so limit at so as x tends to 1, g of x is equal to 2, and as x tends to 1, limit is equal to 1. So now so as you can see, this particular limit is non-zero, right? So now I can apply this particular. So this is basically limit of h of x at 1, which is 1, limit of g of x at 1, which is so the answer is 0.5. If you apply this thing, as some of you already suggested, that you can actually directly put x is equal to 1 here. So why you can put actually this is this g of 1 is non-zero. That's why you can substitute, but you cannot do the same trick for all the function. For example, this particular function, you cannot do the same trick here. Because when you are applying, when you are substituting one, before that you have to make sure that yeah, so both the limit they exist and they are equal. Okay, so okay, let's try to calculate the left hand limit. Okay, so I'll do for one case. Okay, so for example, I'll try to compute the left hand limit of this g of x, which is basically x minus 3 x minus 2. So we want to know so similarly the same thing, right? So you have this function x is equal to minus 3. So what will be the graph of this function? At x is equal to 0, it's minus 3. At x is equal to 1, it's minus 2. So this is x equal to 1. So you want to compute the left hand limit at x is equal to 1 for this function. So as you can see, we are coming to this point 1, then your function value basically approaches to minus 2, right? So that's why the left hand limit of this function at 1 is equal to 2. And similarly, you can compute the left hand limit of this function and you can get the left hand limit of this function. And obviously it's clear like how you can compute the left hand limit of this function that is x. So using that you can compute the left hand limit of f of x. Is it clear?
Yes, sir.
Okay. Yeah. So just now, like some of you asked whether I can directly substitute the value of the function to get the limit. So this is the example. You cannot do it because if you substitute f of 0 is equal to 0, then what you will get? 0 by 0. So you cannot do that. Like you have to, yeah. So the thing is, you have to make sure what that function is nice. So and obviously, and yeah, that this particular thing is not 0. That value of that h of x is not 0 at x is that at that point. So okay. So my function is x square mod x. So now mod x is x if x is greater than equal to 0. Okay, so the thing is in some sense this is wrong. So the correct definition is this is the correct definition. So the domain of this function, so the domain of this function is r minus 0. This is the domain of the function. So f is basically a map from r minus 0 to r, and we want to know what is the limit of this function at x is equal to 0. And yeah, so as I already mentioned, like it doesn't matter whether this function is defined or whether the function is not defined at that particular point where you are trying to compute the limit. Okay, so the basically the value at that point is completely irrelevant when you are talking about limit. So mod x is x if x is greater than or equal to 0. So am I audible?
Sir, I
Yes,
don't
sir.
understand this step, what you have just written.
Yes.
So
yeah.
mod x, it will never be equal to minus x if x is lesser than 0. That's where, I mean, if we are saying mod x,
Yes.
irrespective of x greater than 0 or lesser than 0, it will always be positive.
I got your point. Okay, let me. So what is mod of minus 2?
2.
Plus 2.
This is what?
This is plus 2.
2.
2, right?
Yes.
Yeah.
So this is basically minus of minus 2, right?
Yes.
Yeah.
That
Yes,
is what I have written here, right? See, x is negative, minus of x is positive, right? This is positive, right? If x is negative, then minus of x is negative, then minus of x is positive, right? I'm
Okay.
getting a positive number here. See, minus 3. What I'm getting? 3, which is basically what?
Minus of minus 3.
3. That is
Okay.
basically
Okay.
minus of x. Right?
minus sign is to make it positive.
Yes. True.
Yes.
So
Yeah, this makes sense. Fine.
Yeah,
Got
yeah.
it. Okay. Okay.
So this particular thing is clear, right? So if mod x is x, if x is greater than or equal to 0, and mod of x is minus x if x is less than 0. So this I can write x square by x if x is greater than 0, because I cannot include x. I cannot include 0 because the function is not defined at 0. Okay, so as I said, the correct definition is f of x is equal to x square by mod x when x is not equal to 0. Okay, so this I can write x square by minus x if x is less than 0. So what I am getting, x if x is greater than 0 minus x if x is less than 0. So this is finally this is my function. This is in some sense in some simplified form. So this is the function, and what I am trying to compute, I am trying to compute the limit of the function at 0. So the left hand limit. So the left hand limit. So what is, if x is greater than 0, the value of the function is
Positive. X.
And if x is less than 0,
Minus x.
so this is the function, and this point is not included. So as you can see, when you are coming to 0 from the right hand side, this value of the function is basically approaches to 0. So in the same logic, like can use the same logic when you are coming to 0 from the left hand side, you can easily see that the value of the function approaches to 0. So both left hand limit and right hand limit, they are 0 and they are equal. So that's why the limit of this function exists and that value is 0. Is it clear?
Yes, sir.
Okay. No, like Archit, no, it's certainly it's. So are you talking about the limit or the value of the function at 0?
Sir, I'm talking about the limit. Actually, it is a discontinuous function, sir, as we see in the graph. Okay, at 0, it is discontinuous. So, from this question, we conclude that every discontinuous functions exist a limit, right?
Sorry.
From this one, sir, we can conclude that every discontinuous functions exist a limit, right?
No, discontinuity doesn't imply anything.
Okay.
See, if limit doesn't exist, then you can say that the function is not continuous. Okay. If the function is not continuous, then you cannot say anything about the limit. Okay. So if you know that limit doesn't exist, then you can say that the function is not continuous. Okay. If you know that the function is not continuous, then you cannot say anything about the limit. The limit may exist and the function is not continuous. That can also happen, right? The limit exists, but the function is not continuous.
For example, sir, which
This
example?
particular. Sorry.
For example, the function is discontinuous and the limit exists. This is a mod function.
Sorry.
This function is, I think.
This is
this
the function,
example
right?
is, yeah, this is a discontinuous function and its limit
This is
exists.
yeah. So the function is not defined at 0. So there is no, yeah. So discontinuity, like in some sense, doesn't make any sense. Like yeah. So
But this function, I'm sorry, please one.
Just I will extend this function. Okay. So what I will do, I'll do one thing. This is my function.
So can I tell a function which is discontinuous and has a limit?
Sorry, just a minute. Let me complete this. Okay, the thing is, I don't want to discuss about continuity, but okay, let me give you one example. So what you do, you define this function at x is equal to 0. The value of the function is 5. Okay. This particular function, the limit 0, limit of this function at 0 is 0, but f is not continuous. So basically for continuity, what you want, the limit should be equals to the value of the function at 0, which is 5. So this is not true. So f is this particular function at x is equal to 0, the limit exists, but the function is not continuous at x is equal to 0. Okay. So the what basically I did here. So I just extended the function. So this my original function is a function from r minus 0 to r, but this function is from r to r because I defined the value of that function at x equal to 0, that is 5. Okay. So yeah, so this is the example. So what I was trying to say that limit, if limit doesn't exist, then you can say that the function is discontinuous. But if the function is discontinuous, you cannot say anything about it. Is it clear?
Sir, but why are we not including?
Sorry.
for when we had started the problem, it was given that x squared by mod of x. So of course we are excluding x equal to 0 in that case, because that will lead to because it will lead to an undefined function. It does not exist. But now that we have defined the function down to, or rather we have evaluated it down to x and minus x for the values of greater than 0 and negative of 0. Why are we not including 0 anymore as x? Because now we can define it at x equal to 0. It will basically be 0. I mean, it will be approaching 0 in that sense.
No, then if see, the thing is what I was trying to say, that whatever statement he is saying, that is wrong. Okay, so if you will make it 0, then the function is continuous at 0. That is fine. But
no, what I'm not understanding is fine. You just said 5 to help him explain. I mean, help the continuity part explain. That's fair enough. But the function by itself, f of x equal to x and minus of x at x greater than 0 and less than 0, it is very well defined at 0, because it would be 0. I mean, unless it is.
No. This expression tells you that it's not defined at
this
0.
expression. Yes.
Yeah,
so if we are evaluating it down to what we just now did and got it down to x and minus x, we can't let go of that of the fact that it cannot be 0. We still have to uphold that.
So it's in your hand. Like you can define whatever way you want. Like you can make it 0, you can make it 5. Like see, the thing is, what is your aim? That is what it matters. Okay, so yeah. So the thing is, why I defined at x is equal to 0, the value of the function is 5, because I want to contradict his statement. Yeah.
Right. That it could be having a. Okay, anyway, it doesn't matter. X equal to 0 is also not the same. The same
yeah, you can, like, as I said, like you can define 0. If you define it to be 0, then this will become a continuous function. Okay. So yeah. So anyway, so I don't want to spend time on continuity, because anyway you are going to see all these things in the upcoming session. So yeah, so okay, so the next this is probably the last question. So the option 1 is basically what it's saying, as x tends to infinity, what is the, so where f of x basically approaches. Right. So for example, like as you see this as n tends to infinity. So
background noise are too much to understand.
But you are getting noise. Okay, I don't know. Like certainly it's not coming from.
Not from yours, sir.
Yeah, from my end. Yeah. So yeah. So okay. So I want to discuss. Yeah. So the limit of the function. This is my function. So what is the limit of the function when x tends to infinity? So as you can see, as n tends to infinity, suppose you take this sequence xn is equal to n. So this sequence basically tends to infinity. So if you compute f of xn, which is n, this tends to 0. So the point is, as so if x is large, 1 by x is small. So the thing is, so if x tends to infinity, 1 by x tends to basically 0, because yeah, so the thing is, yeah, if you increase the value of x, then certainly the value of x, so you will get a very small value of 1 by x, because yeah, so similarly you can check if x is equal to n square, or maybe some sequence you can take which converges to infinity, then you can easily check that 1 by x basically that sequence converges to 0. So yeah, so the first option is correct. So the second option is as x tends to infinity, so this is in some sense, so if x is large, then x square is much more bigger than x, right? If x is suppose 10 lakh, then 10 lakh square is much more bigger than 10 lakh, right? So if x is large, then x square is much more bigger than x. So it's in some sense x square is much more bigger than 1 by x, but it's saying that if x tends to infinity, this quotient is basically converges to 1. So in some sense this is not possible. So as you can see, so what do you mean by this x square by 1 by x converges to 1 as x tends to infinity? In some sense it's saying that as x tends to infinity, x square is somewhere near to 1 plus x. So in some sense it's not true, because as I said, like if x is large, then x square is much more bigger than 1. Yeah, so in some sense it's not true. Yeah, so that is my point, but we can do it mathematically. So what I'll do now, I'll divide x in both denominator and numerator. So what I will get, x by 1 plus 1 by x.
So 1 by x square, no?
Which one?
X by 1 by x square plus 1 by x, no?
If I'll divide by x in
okay, I'm sorry, you are dividing by x.
So as you can see, this converges to 0, this is small, and this converges to this, in some sense diverges to infinity. So big by small, like in this is because this converges to 0, so you will get a much more bigger number. So this particular limit basically diverges to infinity.
Sir, one question here.
Yes.
In the denominator, it's written 1 plus 1 by x. So this entire expression converges to 0, or just 1 by x converges to 0?
1 by x converges to 0.
So denominator has still 1, isn't it?
Yeah. Sorry. Yeah. True. I made a mistake. But okay, certainly it's not going to affect the result, but okay. So this converges to 1, and this diverges to infinity. So in some sense, what you are getting, limit limit x tends to infinity. So in the so here this basically diverges to infinity, and here you are getting this particular term is converges to 1. So yeah, so what you are getting a big number, and by 1. So this particular thing, it diverges to infinity. So when you will take limit, you will get infinity. So is it clear what actually I was trying to say? Hello?
Yes, sir.
Yeah. Sorry, Harshit, what do you mean by solution?
No, sir. Actually, I posted 2 questions in the chat box, which I want to get a solution from your side.
Okay. So yeah, so
This is true, no, sir?
Sorry?
This one is right, no? True.
Which one is right?
Option third.
Yeah, it's right. Yeah. So, but still now I have not discussed option 3. Hello?
Yeah, sir, please go on.
So yeah, so in some sense, yeah, so this is basically what? One x. So this basically converges to 1, and this diverges to minus infinity. So this is, in some sense, this is a fixed number, and this is something huge. So then certainly this will converges to 0, because this, as you know, so in some sense this particular sequence, if you take this sequence, if you take okay, what is the issue here? Just a minute. Oh, yeah. So if you take this particular sequence 1 by n, so this diverges to minus infinity, but this sequence 1 by minus n converges to 0. So this is particularly the same scenario. So this 1 by x plus 1 converges to 1, but this x diverges to minus infinity. So below you have something huge, and above you have 1, like that is very small compared to the below. So the limit will converge to 0. The next thing is x tends to infinity, 1 plus x square so you have x square here, you have also x square here, and now you can divide x square, but 1 by x square plus 1 by x plus 1, this is 5 plus 1 by x. So as x tends to infinity, this is 0, this is 0, and this is basically 1. So the whole, this particular thing converges to 1, and similarly this converges to 0, and the whole thing converges to 5. So that implies the limit of this function, this particular function f of x, is basically limit of this function, the above function, and limit of the below function, which is 1 by 5. And same thing I guess you can do here. This is wrong, because if you divide x to the power 2021, so what you will get? You will get 1 by x. This is the above one, 1 by x. 1 by x to the power 2020 plus 1 by x to the power 2021. So as x tends to infinity, this is 0, and all the other terms, they converges to 0. So that implies the whole expression converges to 1. And similarly, you can say that this particular expression, because if you divide, then what you will get? You will get same thing, 1 by 2021 into 1 by x. So 1 by x converges to 0. So then 2021 into 1 by x also converges to 0. So as x tends to infinity, this expression converges to 1. So that implies the limit is 1. So this is wrong. So is there any doubt from this question?
No, sir.
Okay. So I'm done. Like, you can ask your question.
Sir, I have a question. I understand graded assignment cannot be discussed, but maybe you might want to give some clues from that particular question and help us solve that question. It is graded assignment 1, question number 5.
Okay. Okay. Yeah. Harshjit, it's true. As n goes to infinity, I don't know to whom you are saying, but yeah, the statement is true. Okay. So let me stop. Yeah. Yeah. Okay. Yeah. Okay. Let me check the question.
Thank you.
Excuse me, sir.
One by one. Let me see question. Week 1 graded assignment. Question number 5, right?
Yes, sir.
Yes. Yes. So what is the issue here?
Sir, I am not able to follow the right approach to solve this, because the limit n tends to infinity is given in the question. However, the clues are limit extending to 0. And I am not able to understand this reversing of the, what should I say, terms in the equation in order to use the hints. How do I do that?
Okay, so one thing maybe you are missing. This part, the bracket part is certainly you can get it from this given thing. Here you are getting 0. And here you are getting 0. Yeah, like, yeah, it's easy. Okay. So the thing is, so for in some sense, like as you know, like you can take the limit inside of the of a function, right? So, for example, let me share my screen. So basically, what you need to use. So suppose you have this thing f of x, and you want to compute. So suppose a is some number. So then actually you can take the limit inside. So this is basically log of so yeah. So this you know this property.
Yes. Yes.
And probably another thing you need to use, for example, suppose you have some function. Suppose you have some function f of x. So you want to compute limit of the function rt. Suppose you have suppose you are facing some problem. Suppose this function is little bit complicated, but if you apply log here, then you are getting, suppose you are getting a easy function. So now if you compute the limit of this, okay, suppose this is basically a, not log, this is ln. Then if you apply e both side, then basically what you will get? Right? This you know.
So trying to understand what you have done. Yeah.
So, and for example, you have suppose you have this like so yeah, so I guess now you can get the answer, like that is this particular most likely this particular thing is I guess enough to compute the value. Yeah.
Excuse me, sir.
Any clues that you can give in terms of uh, regarding n approaches infinity when we see in the problem and n approaches 0 in the clues? Is there any relation or any property that we can use between limits approaching to infinity and limits approaching to 0?
That you just interchange in terms of so instead of x you can use 1 by x.
Okay, so if x approaches infinity and the term is x, then you mean to say x approaches 0 and the term can be 1 by x, right?
Yeah.
Okay, fine. Okay.
So suppose you have this, suppose like log of 1 plus x. So this is what basically this is so you replace y as 1 by x. So this is what limit y tends to infinity log of 1 by y, right? So yeah, so in some sense you can change your function, and so that you can change your limit from 0 to infinity.
Okay, sir. I'll try basis what you have told. Thank you.
Yeah.
Excuse me, sir.
Someone asked
Sir, when are you going to provide a detailed solution of practice assignment?
a practice assignment that I have to ask, like I think it's done, but you should so when
Because till previous term, you used to provide a detailed solution quite well in advance before the last date of graded assignment submission.
so when is the last date of
Graded assignment is tomorrow.
Oh, still now. Okay. So yeah, I'll talk to Subhajit. Yeah.
Because previously you used to give, at least in PDF form, you used to give a detailed solution, which was quite helpful for us basically.
No, that is certainly, it's not a problem. Like you need solution. It doesn't matter whether it's in PDF form or it's in written, no? But the solution has to be clear. That is what you need.
Right,
so,
right.
Yeah. So I'll so as far as I know, the solution is with us, but I don't know why they have not uploaded it. Okay, I'll inform.
Okay, thank you, sir. Thank you.
Yeah.
Waiting.
I'll tell them to do it today. Yeah. Sorry.
Okay.
Yeah. So the next okay, so someone asked so many questions, so certainly I'm not going to solve all the questions. Okay, so activity question 6, 8, 9, activity question 4, activity 4 question 6, and no, you have to do it. Like it's basically you're asking me to solve the activity question, like week 1 activity question. Any specific doubt? Hello.
Hello, sir.
Yeah.
Good evening, sir.
Okay, like you, please one like
Sir, I have asked these questions, sir. Then can you explain the important from these questions?
No, like it's important means it's like you have asked so many questions. Like basically you have asked 3, 3, 6, 7, 8, 9. Yeah, so 9 questions. Like if I start solving all the questions, then yeah, I have to spend all the time on your question.
Sir, actually, I am having problem in solving these questions, so I asked.
Okay, like okay, so the thing is, I'll suggest you to use discourse in that case. Okay, so in
Okay.
in this course, as far as I know, you can get solution of almost all the questions. Okay.
Yes,
So,
sir.
so certainly in live session, it's not possible for me to solve 9 questions only for you. Yeah. So,
Sir, can you tell me some questions today?
Hello, sir.
Okay, I'll suggest you to, like, if you have some doubt specific question, then ask me. Like, you want some specific question, I cannot pick a question for you. Okay, you have to pick it for you. Okay.
Okay, sir, I will tell.
Okay, so yeah, so you check and you can tell me after sometime. Yeah, you check. Huh?
Hello, sir.
Yes.
Sir,
Yes.
practice assignment, second question, second statement.
Second question. Yes, yes, yes. What is so? What you want to know?
I'm not getting the logic behind. Means like product of two sequences which are diverging, and then the product may lead to convergence.
So it's the statement is an times bn may converge even either an neither an nor bn converge, right? So you want to know whether this statement is true or not. So you can see the screen, right? Hello. Hello.
Yes, sir. Yes.
Yeah. Yeah, so it's saying that A and Bn converges, but neither An converges nor Bn converges. Okay, so it's saying that you can have a sequence, you can have two sequence A and Bn such that both An and Bn they don't converge, but their product is a convergent sequence. So any idea, like?
So I was just like guessing A and B, X and B and B X square.
Okay,
and
so
product does not lead to convergence.
So suppose I take a sequence AN. So the first term is 1, right?
Okay.
Second term is maybe -1. Third term is 1. Fourth term is -1. So this is this sequence. What is the limit of this sequence?
No limit.
Yeah. So this is not a convergent sequence, right?
Yes. Sir. Yes. Sir.
Now you take Bn. The first term is -1. Second term is 1. Third term is -1. Fourth term is 1. So what is the limit of this sequence? So A and Bn. So what is the limit of this sequence?
No limit. Sir.
No limit. So both An and Bn they don't converge, right?
Yes.
So what is An times Bn? It's
-1, -1, -1.
So what is the limit of An times Bn?
Okay, sir. So -1. Thank you.
Yeah.
So I got it. Thank you, sir.
Yeah.
So can I ask?
Yeah, please.
It's from the graded assignment, not the answer I'm asking. I just want to clarify the question. Find the limit of the sequence, and the sequence is given. Then whether it is asking when n tends to infinity like that, or the converging value.
Oh, question number
6.
Yeah, it's basically is asking where this thing actually converges.
Okay.
So the thing is actually you need to find a final value of this. So it's basically asking what is this. Okay. If you can write this one. So if you can write this one in terms of n.
Okay.
See, you know something about 1 plus 2 plus 3
Yeah.
up to n, okay, which is basically n into n plus 1 by 2. Okay. So yeah, so then you know, like sum of odd natural numbers, like suppose I am taking 1 plus 3 plus 5 some 2n minus 1.
Okay.
So what is this value? So if you know the value of this, you know the value of this, then you can compute the value of this.
Okay.
So yeah, yeah. So the thing is, even you just need to add 1 plus and 1 minus, right?
Yeah.
So then basically what you need to compute? You need to compute the value of first n odd numbers, right?
Yeah.
So okay, so the thing is, yeah, so you have to do it. Okay, so okay, so the thing is, you try to add the even numbers and you try to add the even numbers. Okay, so what you
Okay.
can do, you can take 1 plus 2 plus 3 plus 4 okay. So this sum is basically this sum minus 2 plus 4 plus 2n, right?
Yeah.
So now you know this sum because you have this formula, right?
Yeah. Yeah.
Now you take 2 common from this. So you get this sum. You have this formula, right?
Yeah.
So then you get the total sum, right?
Oh, okay.
So you got my point, like what I was trying to say.
Yeah. Yeah.
Yeah.
Yes. Sir.
So this is just, yeah, some addition, like you have to subtract some even numbers and you have to add it. Yeah.
Okay. Thank you.
Yeah.
Sir, can you please tell question number 3 or 8 of activity 3?
Activity 3.
Question number 8.
Yeah, so what is the problem here? Question 1.3, question number 8, right?
Yes, sir.
Yeah, so what, like, where you are facing problem, like?
Sir, it's about finding the lower bound and I don't understand how to find it.
So how many points so whether at point P the tangent exists or not?
Wait a minute, sir. I have to see the question.
Okay.
Sir, there is no point P, sir. It's let A be the set of point where the curve C. Wait a minute, sir. Sir, P at point P. Yes, sir. There exists a tangent.
So there, what is that tangent then?
Wait.
Say, like, can you tell me, like, when so the thing is, have you watched the lecture, like 1.3?
No, sir. There doesn't exist the tangent, sir. Tangent tell the direction of the curve.
Yeah.
And it doesn't means it is one at a particular point means there are no it doesn't touches the 2 points means it have to be unique.
Yes, true. So yeah, so
So so at point P it doesn't exist. There is
yeah,
no tangent.
yeah, so this is the point P. Okay, right? So as you can see, this function actually changes his direction suddenly, like it's a huge change. Okay, so as you can so you can have multiple tangents here. Okay, so if at a point you have multiple tangents, that implies actually that that implies the tangent at that point is not unique. So that's why this particular at that point at point P you have no tangents. Okay.
Okay, sir.
So similarly, you can check that at point Q also you don't have any tangents.
Yes, sir.
Yes. And
Sir, but
similarly,
the question has asked about the lower bound, and I don't understand means how to find out the lower bound.
so in picture you have only 4 points, right? One,
Yes,
two,
sir.
3, 4. So then lower bound is 4, right? Because it's saying that so in picture it's clear that you have 4 points where where the function has no tangents, right?
Okay, sir.
So then answer has to be 4 because you have only 4 points. So the lower, see, here you have some in some sense it's not the complete graph of a function because I cannot draw whole real line here, right? So it's a part of a function. Okay, that's why we have asked you the lower bound because you don't know how the function behaves after that, after maybe, yeah. So this is not a complete graph. This is
Okay, sir.
it's a part of a graph. Okay, that's why we have
Okay.
asked you the lower bound. So in the graph, it's clear that you have 4 points where you don't have any tangents. Okay, so
I got it, sir.
okay.
And sir, in the question number 6, I don't know how to find the cardinalities.
So what is the definition of a graph of a function?
Graph means it can be represented by x comma y, where y is the function value and x is the point where it and it is defined on the x comma y.
So if you have a function from A to B, then graph of the function is what? X comma,
It is the pictorial representation of that function.
so this is basically x plus f of x, right? Where
Yes, sir.
x belongs to A, the domain of the function,
Yes, sir.
right? So if
And y belongs to the codomain.
yeah, so the thing is, if x is in A, then you are getting a point x comma f of x in gamma of f, that is the graph of f. And similarly, if you have a here in the graph of the function, then you will get element x in A. So what basically it's giving? It's giving a bijection between A to gamma of f, right?
Yes, sir.
So basically what it's saying, the cardinality of A is same as the cardinality of gamma of f, right? So
Yes, sir.
so what I'm trying to say, suppose you have a function from 1, 2, 3 to 1. So at 1 the value is 1, at 2 the value is 1, at 3 the value is 2. Okay, so what will be the graph of that function? What is the graph? You have 1 here. For 1 you are getting 1 comma 1 comma 1.
1. And for 2 we are getting 1.
2 comma 1. Okay, that is the definition of graph. See, graph definition is x comma f of x. Okay, so this is x, this is f of x, this is x, this is f of x, and for 3 you are getting
3 comma 2.
So that is what I am saying. So if you have a 1 here, you have 1 comma 1 here. If you have 2 here, you are getting 2 comma f of x, 2 comma f of 2. If you have 3 here, you are getting 3 comma f of 3. So the cardinality of the domain is same as the cardinality of the graph of the function, because for each point in the domain you are getting a f of x. Okay, so and for each f of x you have a x in the domain, so it's a bijective one-to-one correspondence. So yeah, is it clear?
Yes, sir.
Okay.
Thank you, sir.
Thank you. Okay, any other questions?
Sir, I have a dot in practice assignment question number 1. Sir, can you open the question?
Which one?
Practice assignment question number 1.
Question number 1.
Yes, sir. Question 1. Sir, in the option, in the second last option, monotonically increasing. If the interval is from pi to minus pi to pi.
Minus pi to pi, yeah.
Yeah, then what would be the answer?
Then it's neither monotonically increasing, neither monotonically decreasing. Yes. Because,
how, sir?
Because in some parts it's increasing, in some parts it's decreasing, right?
Okay.
So that's why it's neither monotonically increasing. See, if it's monotonically increasing means it has to be monotonically increasing throughout the interval. Okay, if it's monotonically decreasing means it has to be monotonically decreasing throughout the interval. But as you can see from minus pi to pi, okay, so it's
okay.
So first it increases, then it decreases, then increases, then it decreases. So some sense it's a oscillating behavior, right? So that's why it's neither monotonically increasing nor monotonically decreasing.
Okay.
Got it?
Yes, I got it.
Yeah.
Hello, sir. Sir, in this same question, there is option given as a unique tangent at x is equal to pi and minus pi. So what does mean unique tangent? Because at both this point, the tangent is same. Does the unique tangent mean that tangent is present at this point?
Yeah, no. They have same tangent, but the question is in both like at x is equal to pi, you have a unique tangent, and at x is equal to minus pi also you have a unique tangent. That is what this statement is all about. Yeah.
But at this point, the point is having the same direction at pi and at minus pi.
See, at pi and minus pi, at pi and minus pi, you have the same tangent, right? But that is unique, right? In pi, you have a unique tangent. At minus pi also, you have a unique tangent. Hello?
Yes, sir, yes.
So you got my point? Like, hello?
Means it is not comparing the tangent of x is equal to pi and x is equal to minus pi.
No. It's basically it's saying at x is equal to pi, you have a unique tangent, and also at x is equal to minus pi, you have a unique tangent.
So unique means single. Means
Yeah.
one.
See, if the tangent is unique, then only you can say that the tangent exists. Okay.
Yes.
So if you have multiple tangents, then actually the tangent doesn't exist. Okay, that is by definition. Yeah.
Yes, sir. Thank you.
Yeah. So any more questions? Okay, then I'll stop the session now. Okay, thanks.
Thank you, sir.
Thanks.
Thank you so much, sir.
Thank you.
It was a beautiful session.
Yeah, thank you.
Thank you, sir.
Thank you, sir.
Sir, when will be the next session for week 2?
Week 2 next maybe Tuesday.
Okay.
It is on Thursday.
So will it be the topic specific session?
No. This is the session will be on
activity question.
Thursday. Yeah, activity question.
All right.
So like the first 1.5 hour mostly we'll do questions from activity. Okay. After that you can ask your doubt, like something related to week 1 or something related to week 2. You can ask your doubt. Okay.
Okay, sir. Thank you so much.
Okay. Thanks.
Sir, what about the PDF answers of practice assignment?
Yeah, I'll talk to Subhajit now. Okay, yeah. And
Okay,
mostly we'll upload it today. Yeah.
okay, sir. Thank you.
Okay, thanks.